When NVIDIA's H100 ramp slipped through 2024, the bottleneck was not silicon. TSMC had the wafers ready. The bottleneck was not the advanced packaging tools. ASML had nothing to do with it. The bottleneck was a paper-thin sheet of glass and resin, a few centimeters across, made by a Japanese chemistry company that started life-selling food seasoning. That material is called ABF, Ajinomoto buildup film, and it sits in the middle of every modern AI accelerator. Two companies in the entire world know how to laminate that material into the finished substrate that holds a chip. They are Ibiden of Japan and AT&S of Austria. Almost no one outside the semiconductor supply chain has heard of either. And without them, the entire AI build-out grinds to a halt. The substrate is the layer between the silicon die and the printed circuit board. It carries thousands of fine wires that fan out from the chip pads to the system. For an AI accelerator, the substrate is the most complex piece of packaging on the entire planet, sometimes 90 millimeters on a side, with more than 20 layers of copper drilled with hundreds of thousands of microvias and laminated under conditions that look more like semiconductor manufacturing than printed circuit board work. Globally, the advanced flip chip substrate market is roughly $8 billion per year. Ibiden, headquartered in Gifu, Japan, holds the largest share at the most advanced end, somewhere around 30% of high-end ABF substrate volume. AT&S, headquartered in Leoben, Austria, has spent the last 5 years aggressively expanding into the same segment, with a new mega facility in Kulim, Malaysia. Together, they are the only two companies qualified to produce the largest, highest layer count substrates that NVIDIA's CoWoS-L packages require. Over the next 10 minutes, we will look at 4 things. First, what Ibiden actually is, and why the company that supplied Intel's chips for 30 years became the gatekeeper of the AI roadmap. Second, how AT&S, a European outsider, built a credible alternative. Third, the strange origin story of ABF film itself, and why a food company holds a monopoly on the resin that goes into every advanced substrate. And fourth, why the CoWoS-L substrate is the single hardest piece of the AI compute stack to scale. Start with Ibiden. The company was founded in 1912 as the Ibi River Hydroelectric Company. For its first 50 years, it sold electricity, then ceramics, then printed circuit boards in the 1970s, then advanced multilayer substrates in the 1990s. Today, Ibiden is the most concentrated bet on high-end IC substrate in the world. Roughly 70% of company revenue comes from semiconductor substrates. For 3 decades, Intel was Ibiden's anchor customer. Every Pentium, every core processor, every Xeon, almost all of them sat on an Ibiden substrate. That long Intel relationship gave Ibiden the qualification trail and the process expertise that newer entrants simply cannot replicate. As Intel's share of the leading shrank and NVIDIA's AI accelerators became the new high-volume premium customer, Ibiden quietly transitioned its production lines toward CoWoS-L substrates. Today, the Gifu Prefecture facility is the single largest source of advanced ABF substrate on the planet. Revenue in fiscal 2024 was approximately $3.5 billion, with operating margin in the mid-20s%. Capital spending has been running above $2 billion per year, most of it building new ABF substrate capacity on the same campus for the same customer base. Ibiden's structural advantage is hard to describe in a single sentence. It is part chemistry, part precision manufacturing, part decades of qualification with the world's most demanding customers. Replicating that stack requires not just money but time. New entrants need 5 to 7 years from announcement to qualified high-volume production. Ibiden has had 80 years of head start. AT&S, the full name is Austria Technology and Systemtechnik AG, took a very different path. The company was carved out of an Austrian electronics conglomerate in 1994. For 2 decades, it was a mid-sized European PCB maker, well-regarded but unremarkable. Around 2017, the leadership team made an aggressive strategic decision. They would not be a printed circuit board company anymore. They would become a premium IC substrate supplier, competing with Ibiden at the highest end. The bet has cost approximately $2 billion in capital, most of it deployed into a new mega facility in Kulim, Malaysia, dedicated to advanced ABF substrate. Today, AT&S is the only meaningful European headquartered supplier of high-end semiconductor substrate, with roughly 15 to 20% of advanced ABF capacity globally. Revenue in fiscal 2024 was about $1.7 billion. Operating margins have been compressed during the capacity ramp, but the long-term thesis is straightforward. AT&S gives the West a substrate option that does not require routing the entire AI roadmap through Japan and Taiwan. AMD, NVIDIA, Intel, and the major hyperscaler ASIC programs have all moved volume onto AT&S as a second source qualification, often in parallel with Ibiden. The Kulim plant is now ramping, and AT&S is publicly committed to building additional advanced capacity through the late 2020s. There is no third Western alternative. The Asian competitors, Unimicron and Nanya in Taiwan, Samsung Electromechanics in Korea, are larger by absolute volume but still trail Ibiden and AT&S at the most demanding layer, counts, and substrate sizes. Here is the part of the story that makes the substrate duopoly possible. ABF stands for Ajinomoto Build-Up Film. Ajinomoto is a Japanese food company. They invented monosodium glutamate in 1908 when a chemistry professor named Kikunai Ikeda isolated the umami compound from kombu seaweed. For more than a century, Ajinomoto has been one of the largest food ingredient producers on Earth. But the company's chemistry expertise in glutamate-derived amino acids and epoxy resin chemistry led them, by accident in the mid-1990s, to develop an insulating film with electrical and thermal properties, unlike anything else in the industry. They called it Ajinomoto Build-Up Film. ABF turned out to be the only material in the world that could survive the laser drilling, copper plating, and lamination cycles of advanced substrate manufacturing while keeping signal integrity at the frequencies modern processors require. Today, Ajinomoto Fine Techno, the subsidiary that produces ABF, has essentially 100% global share of advanced build-up film. A food seasoning company became a monopoly supplier for the AI economy. Below ABF, the substrate stack also requires copper-clad laminate, the rigid core, supplied mainly by Mitsubishi Gas Chemical and Hitachi Chemical. Above ABF, drilling and plating require specialized equipment from Japanese and German vendors. And the substrate assembly itself, laminating dozens of ABF layers together, drilling hundreds of thousands of microvias, electroplating the copper, and testing every connection, is the proprietary process that only Ibiden, AT&S, and a small group of Asian substrate makers know how to do at advanced node scale. Now, to the specific reason AI accelerators are so substrate constrained. A typical mobile processor substrate is about 20 by 20 millimeters. A high-end CPU substrate is closer to 40 by 40. An AI accelerator using CoWoS-L can require a substrate 70 by 90 millimeters, or even larger. Substrate yield falls exponentially with area. Every additional square millimeter is one more place where a single defect, a misaligned via, a hairline crack in the resin, a contaminated copper layer, kills the entire part. And the entire part can cost $300 to $500 before any silicon is even attached. A single yield excursion on an advanced AI substrate is a multi-million-dollar problem for the supplier and the customer. CoWoS-L makes the geometry worse. CoWoS-L places multiple large silicon dies onto a silicon bridge interposer, and the entire bridge module is then mounted on the organic substrate. The substrate has to support the mechanical load, the electrical load, and the thermal expansion of a package that can weigh 5 times more than a normal CPU package. This is why the 2024 NVIDIA H100 supply constraint was not silicon and was not packaging tools. It was substrate. Ibiden and AT&S were running at full capacity with multi-year lead times on a substrate format that nobody else in the world was qualified to produce in volume. 2025 and 2026 bring new capacity from both companies, but the demand from B100, B200, Blackwell Ultra, and the next generation hyperscaler ASICs is growing at least as fast. The substrate squeeze is structural, and it is not ending soon. Here is the verdict. 2 layers mirroring every previous episode in this series. Ibiden first. Founded in 1912, 80 years of substrate manufacturing experience. The largest concentrated bet on advanced ABF anywhere on Earth. $3.5 billion in revenue, mid-20% operating margin, and capital spending above $2 billion per year going into new GPU capacity. Intel was the anchor for 30 years. NVIDIA is now the anchor for the next decade. Ibiden's structural advantage is the combination of deep qualification trails with the most demanding customers and the longest accumulated process expertise in the industry. AT&S second, the Austrian alternative. Smaller, $1.7 billion in revenue, with margins temporarily compressed during the Kalim ramp, but strategically essential to any Western customer that does not want all of its substrate volume routed through Japan and Taiwan. AT&S is the only meaningful second source at the most advanced layer counts and the largest substrate sizes. Together, these two companies are the gating constraint on the entire AI compute build-out through 2028. 3 risks worth tracking. 1. Taiwanese substrate makers. Unimicron, Nanya PCB, and Kinsus are improving rapidly and have larger absolute scale, particularly at sizes below 70 millimeters. 2. Substrate technology transitions. Intel has publicly committed to glass substrate technology for advanced packaging, which, if successful by 2028, could shift volume away from organic ABF. 3. AI demand cyclicality. A CapEx pause or recession would hit substrate suppliers harder than most of the rest of the supply chain because their lead times and CapEx commitments are made years in advance. The pattern remains identical to every other episode. 2 companies, decades of accumulated expertise, customer lock-in measured in qualification cycles, not in switching costs, and an AI build-out that keeps making them more, not less essential. This was episode 3 of Forgotten Monopolies, the companies that almost nobody outside the supply chain talks about, but that decide what the industry can actually build. Next episode goes back upstream into the fab itself, into the quiet American company that decides whether every advanced wafer is good enough to ship. KLA Corporation. Almost nobody outside semiconductor manufacturing has heard of them. Their tools sit inside every advanced fab on Earth. Without their inspection equipment, no fab can run, no yield can be measured, and no advanced node can ramp. The market is one company. The moat is decades of correlated reference data that no competitor can replicate. If this episode taught you something nobody else is talking about, subscribe for the actual semiconductor industry view of the AI race. See you in the next one.